Okay, cool. So welcome for those watching the recording. Welcome to this Git and Collaborative Coding Workshop at Steel City Hack Spinner 2022. This is being carried out live right now, but of course, you should be able to follow along with all the slides and material and perhaps even do the activity yourself if you're watching this in the future. So let's just get started. Right now, what we're going to be talking about is collaborative coding. So we have a couple questions on screen, which you can answer yourself in the recording, or we'll receive some answers here in the chat. But basically, it's important to code together, right? Collaborative coding makes up the vast majority of professional software engineering worldwide, and also a lot of hobbyist software engineering. It's a big component of basically all development of all software across the world, because like most other fields and things, humans like to do things together. So, we took a poll just before beginning this workshop, and people haven't really had too much experience working together on coding projects with other people. And that's what this workshop aims to do. We're going to introduce you to some techniques, to some software, to some sort of like new ways of thinking about code that will help you work in a professional and also in just a hobbyist setting with others on projects together. So if you've ever heard of Git before, you've probably also heard of the word open source. Open source is essentially a set of principles that code will follow to maintain this kind of idea of being very transparent and accessible. So what this means, open source, what it means is that code is publicly available. So anybody can view the code to a project. Anybody can contribute to this project. Of course, this doesn't mean that everybody has edit access. What this means is, and we'll get to this a little bit later, but anybody who wants to add on to this project can sort of create their own copy, make their own modifications, and then request that the original owners of the project take a look and maybe merge those contributions into the main project. So it's a very collaborative process. Anybody in an open source project can build off the original, can add on to their own ideas, can make a copy of the original, and just work off of that and sort of create a new project. Of course, there are licensing and copyright restrictions to this. So open source doesn't mean, of course, that you can just take somebody else's code, call it your own product, and run with it. There are a ton of licenses that protect code owners in various different ways. Some of them are just that, like, you have to mention that the code owner wrote it. Others are that you can't use it for certain things. Others that you need to request permission for certain things. There's a lot of legal complexity that we won't be getting into tonight. But just to clarify that open source is public and is transparent, but doesn't mean that you can just copy and take ideas without any kind of punishment or just being allowed to do that. Open source means that communities are all about crowdsourcing features and feedback. So people will talk about code. People will add new features and talk about those. People will talk about bugs. You can report bugs into this big community setting, into these forums, so that you're basically leveraging the power of a lot of passionate people to work on something all together, versus just having one dedicated team at a company do it. Of course, this doesn't mean that the majority of code is necessarily even open source, but this means that you can create a lot of really powerful products by essentially crowdsourcing them. And finally, before I get into some examples of open source software, this whole idea of transparency does promote much better code and much better practice with that, because if everybody can see how your code is organized, it's much harder to write bad code because people will catch it, people will suggest better code, people will sort of make a big deal about it if you try to get away with something. So it's a really good way to also like proofread it, right? There's a saying that like the best way to get a correct answer on the internet is to post the wrong answer instead of to ask a question. That's sort of what that whole transparency idea is all about. Does anybody in the chat want to name any open source software that they're aware of before I start listing off some examples off the top of my head? Actually, we don't have any prepared, but there are quite a few big ones. Yeah, exactly. Linux, the operating system, which makes up the vast majority of operating systems in use today, mostly on server side stuff. A lot of people don't actually own personal Linux computers, but Linux is still extremely important to the modern computing environment. Linux is all open source. Firefox, the web browser, is open source. GIMP, the photo editing tool, is all open source. Those are the big examples I was going to think of off the top of my head as well. GNU, the compiler, is open source. And Git itself is open source. So the actual like code behind Git is fully accessible to the public and anybody can contribute to it. Of course, assuming the Git maintainers allow your contributions, which is quite rare. So we're going to talk now a bit more specifically about Git, GitHub, and the tools we're going to be using today to do collaborative coding.
So, like Charlie said, Git itself is an open source software, and the big idea behind Git is this idea of version control. So, there's a couple of advantages to this. First of all, it allows people to make changes to software efficiently. So, it's not like maybe trying to log into maybe like literally walking across the office to someone's like personal computer and logging into there and trying to do it on their own computer, but sort of making changes more efficiently, being able to test these changes easier and revert and see changes easier. They sort of go hand in hand, but the fact that you're able to see like what changes in your software is especially helpful. And different branches of the software can be edited. So branches is something we're going to talk about a little later, but you can sort of think of Git if you've ever used Google Docs. It's sort of like um, Google Docs will save the version history. I think it's automatic. Maybe you can do it manually, but if you ever like you're typing out an essay and you just realize you made like a huge mistake in a paragraph, you can sort of try to revert back to a previous one maybe, or try to take some of that information and then revert back to a previous one. And then there's this idea of maintainers that can approve and deny changes from others. And that's where that aspect of like open source doesn't necessarily give you editor access. It's more like what we'll discuss later. There are ways that you can sort of propose changes, but that doesn't necessarily mean they'll always get accepted to the open source system. So yeah. And Git, it's accessed via the console and terminal, so it's locally installed on your computer, which we also talk about later. You can use accounts and keys to access repositories, and a lot of third-party applications plug into Git and offer better user experiences. So one of those third-party applications, which we're going to talk about on the next slide, would be GitHub itself. So you can think of Git like videos in a sense, where they're like sort of locally stored on your computer, and people can obviously like maybe edit them with an editing software, but GitHub is more like YouTube. So that's where you actually upload these videos to like more of a cloud, more of a remote server rather than being on your personal computer. And YouTube interaction, it's sort of the idea that it is public, so people can make comments, people can bring up issues, discussions. I don't think there's a way to like actually have like YouTube users edit your videos, but the general idea of it sort of being public, it's sort of being on a more of a remote server is the same. So GitHub, it gives a pretty easy web-based and desktop clients for Git. I would personally recommend using the desktop client. There's just like, it just feels a lot easier. And then it also lets users host, share, and clone repositories online and locally. So repositories we cover later, but it's sort of, you can think of it as like a coding project that's going to store all of your coding files for now. And GitHub, so like we said earlier, it's all of the features of Git, but it's a nice online interface. So it's like we talked about those third-party applications that use Git at sort of its core, but also add something to it to make your life easier and other developers' lives easier. There's free remote storage for your repositories, and there's features for collaboration, like I was talking about with the YouTube analogy, so people can leave comments, issues, wikis, which are sort of like documentation on your projects, the actual projects, and etc. And there's also features for discovering new repositories. Maybe you feel like just browsing GitHub to get ideas for your own code. So you can look at a couple of open source systems maybe, but yeah. And speaking more about those extra features of GitHub, which we just briefly mentioned. So issues, they're like discussion forums to help fix bugs and propose features. So just like the name implies, right? If you have an issue, you can open up a forum. You could say like, I'm having this bug, or I think GitHub could have this new feature. And pull requests. So they'd offer a place to discuss and review your pull request. So what a pull request basically is, it's sort of like you've like made your own changes, you've made new code, and you're trying to like merge it with the main code project. But that the idea of merging is also something we're going to cover later, so don't worry if you don't understand what that means right now. And then actions and automatic code checks. So software can automatically build and test code to see if it adheres to standards set by some communities and developers. I'm not too familiar with this feature myself, but yes, I believe GitHub does do it.
Yeah, I'll talk briefly about it. So basically what this means is GitHub has a bunch of features that like it automatically will check your code, like run tests against your code or check your code for bugs, or like if there's like particular criteria that you're looking for, you can set up these like special tests and special cases so that like whenever you make a commit, whenever you merge a branch, again, we're going to talk about all that terminology later. The platform essentially is automatically testing it for you. It saves you a bunch of work, and it allows you like to realize if that test fails, you could just revert that change right away.
Yeah, okay. And then some more extra features. So wikis, like I was talking about earlier, it's like they allow community source information about a project, like documentation that's right next to the code. It's sort of something you could find on like any programming. It's similar to what you'd find on like a programming language documentation, like you're just explaining what the code itself does. And then releases. So these are like different packages of software. You might have heard release of releases in a couple of different contexts, maybe like apps, video games, all that stuff. But the essential idea behind them is the same. It's like basically packaging software and like publishing it all at once instead of like trying to keep publishing minute changes. And then projects, they're going to allow developers to track progress. So you can like store a bunch of files under these projects, and projects are stored in repositories, I believe, which we do talk about later. But yeah, so a high level. Oh yeah, excited. Okay, a high level overview of Git versus GitHub. So Git is a software, while GitHub is a website / service that accesses Git itself. Git is a command line tool, so you might have seen commands like git push, git pull, a lot of different stuff that you type in the command line that just starts with Git. That's going to be a Git command. And then GitHub is a graphical user interface that again sort of uses the benefits of Git, but also makes it more accessible to everybody. So Git is installed locally in the system, but GitHub is hosted on the web, and that allows you to have sort of the ability to upload to the cloud and other people can access your code. So Git is maintained by Linux and GitHub is maintained by Microsoft. Git is more focused on, or it is focused on version and control sharing, and GitHub is focused on like centralized source code hosting. But that doesn't mean that like these are necessarily exclusive. It's more of just what these what Git and GitHub specialize in. And then Git is a version control system to manage source code history, while GitHub is like a hosting service for Git repositories. And those repositories contain like the different code files within, all of the changes you make, all of that. And Git does not have like a built-in user management feature, while GitHub does have a built-in user management feature. So that does especially come helpful when you're trying to collaborate with other people. Yeah. So repositories, sort of a slang term for them, repo, but you're going to hear this word a lot. But basically, it's like a representation of a coding project, and it contains branches, which contain files and folders. Branches also something that we do talk about later. So they, the maintainers of repositories, they're going to get to control changes and access to the repository. So like we were saying earlier, the idea of how open source isn't necessarily like open access. It's more of like you can view it, you can make changes, you can propose changes, and you can see if they do get accepted by the maintainers. But usually they do if it's like not going to break their entire system. But yeah, so on GitHub, repositories also have access to other features that promote collaboration and easier coding. I believe one of them was like those automatic code checks, which Charlie was discussing. But the essential idea is that repositories, they're just going to contain like the project's files, your coding project's files, and all of the history that goes behind those files. And then versioning, so all builds of a project would have a version ID. So iOS 13, for example, Minecraft 1.7.10, Android, or yeah, I'm not too familiar with Android, but I guess that's an example. So there's builds for different platforms that will also often have different versions, and Git lets you keep track of these versions through branches, and this sort of ties into version control, which we were discussing earlier. But yeah.
Yeah. So you've heard us say the word branches a lot, and they're definitely a key component of Git. So what exactly a branch is, and you can look at this diagram for like a graphical representation. It's basically just a version of your code. And now I know we just said a branch is a version, and now we're saying like a version is a branch. They're somewhat interchangeable. So basically what it means is it's like a different path of your code, like you can see in the diagram, that's someone is making changes to for a specific purpose. So what we say when we mean version is, with version, you might think of like a big update. like iOS 13 versus 14, or something like Minecraft 1.7.10 versus 1.8.9, right? These are big changes, and those are versions, and you can represent those as branches, and those are branches on their respective repositories. I mean, assuming that they were built with repositories, which I mean, most code essentially is. But branches are also for things just like small bugs, right? So you can create a branch just apply a patch and fix one tiny little bug. And then you can merge those branches in later, which we're going to talk about in a second. But basically, if you look at this diagram, you can see there are 3 branches. The green branch is the master branch, which is now generally conventionally been renamed to the main branch, but this diagram is a bit outdated. There's a new branch, the blue branch, which is a branch that you in the diagram created. And then there's an orange branch, which someone else created. Each circle on this diagram represents what's called a commit. And we're going to talk a little bit more about this in a second. It's basically like a checkpoint, a save point for your code. What Git lets you do is you can create a branch and merge branch at basically any moment, and it handles almost all the difficulties of that automatically. So for example, if you were working on an essay with someone else or some kind of like collaborative, Word project with someone else, and let's say you didn't have Google Docs, right? The best way for you to do that is to start out, like, let's say you're already halfway through the essay and you agree that one person would write the last body paragraph, the last person would write the conclusion. If you don't have access to any kind of like real-time writing service, what you would do is you write the body, your friend writes the body paragraph, you write the conclusion, and then you both send each other what you have and you merge it together onto one file. This can get really complicated when it comes to code because it's hard to interpret and there's a lot of big, like little changes everywhere and also big changes everywhere. Git handles all this stuff really automatically, which is what we're going to talk about with merges. Talking a little bit more about commits. So basically, repositories, because they're hosted remotely, but that you have local copies on your computer, you need to keep track of all the changes made. So it's not, GitHub notably is not like Google Drive or a lot of other sort of collaborative, like Replit, a lot of collaborative things you might have heard of that are real-time synchronized. It's not like that at all. You need to save changes manually, just like a local file system. But the thing is, even when you save a file on your local file system, that change isn't automatically reflected in your local repository or in your online repository. So this is, this is a big point of confusion for a lot of people who just think like a repository is like the files or the folders where their code is in. But actually, a repository is literally your coding project, and it's different than the local files on your system until you commit. So a commit stores all the changes, or rather a commit stores specific changes that you want to store in your repository history. And then you can go back and look at your commit history easily. Commits show exactly which files were changed, which lines in which files, what you changed them with. So they're really, really clear for seeing like what was added or what was changed. And this is super helpful for bugs, because if you change code, you can commit it, you can test it, and then you notice a bug comes up, you can just revert that commit super easily. A small note in terms of the technical aspect of commits is that they make a Git a pretty efficient way to store like code, because it stores changes in files instead of altered copies of the same files. So for example, if you were to have a 1,000-line code document, which is still obviously tiny in file size, but you have a 1,000-line code document and you commit a change in 2 lines, the commit is not storing another 1,000-line code document that has all the other same stuff except those 2 changes. It's just storing those 2-line, what you call a delta. So you're going to see that word a lot if you like install Git or run Git stuff. It's going to say resolving deltas and stuff like that. Those are just changes in files, which are represented in commits. Okay. So basically what this means is if you want to synchronize changes between a remote and a local repository, it's a little bit more complicated than something like Google Drive. So first, you have to synchronize changes by fetching and pulling remote commits. We're going to talk about exactly what these words mean later, but basically a fetch is just checking which commits have happened on the remote end. So you have a local end, which is different from the remote end. You're asking the remote server, hey, what commits have been changed since I've been gone? Which commits do I not have saved on my computer? When you pull those commits, you are saving those changes on your computer now. You are downloading them, you're changing the files. Again, Git is handling all this stuff automatically. So it's not like you have to decide which line the line was changed in goes in your version of the code. Git is handling all this automatically. So you pull those changes. So now your files are the same as the remote files plus your changes. You need to make a local commit, although actually I would maybe make a local commit before pulling those changes. So I guess the slide is a bit wrong. It's a bit out of order. You make a local commit, you store the save, you save the changes you've made onto your repository history. You committed it. Then what you do is you push your local commit back to the online repository. So now the online repository is going to reflect the changes you made locally. So these are some really common words you're going to hear if you work with remote repositories on GitHub, which is kind of most of the point of GitHub, or Git, sorry. It's push, pull, fetch. As another quick reminder, fetch is just to see what changes have been made on the remote end. Pull is to actually get those changes onto your computer, and push is to put your computer's changes onto the online version. These do have to be done in a specific order. You can't push changes if your version is not the same version as the one they have stored. So you cannot push your commits before you pull the upstream. Sorry, upstream is what you call like the online repository, which is ahead of you in changes. You cannot push your changes before you have pulled changes from the remote repository. And that's a mistake that people often make, but luckily Git is quite friendly and it will just tell you made a mistake and it will not break your code or anything. So now what we say when merges. So what we say when we mean merges. So basically, like we said earlier, you can create a branch for any reason, whether it's to fix a tiny bug, whether it's to make a huge upgrade to your code, whether it's just to test a new feature. Essentially, every time you want to make an alteration to your code that might be damaging to the original version, you can make a branch, and Git stores these changes very efficiently. So you don't have to worry about wasting, like, if you have a 10 gigabyte project, you're not going to duplicate your file size just by creating another branch. Because again, it only stores changes to code. So let's say you create a new branch to edit some bugs, or to fix some bugs, I should say, to edit some code and fix some bugs. What you can do is that main branch that you did not touch anymore, that branch can still be updated and accessed by other people. And all you have to do is focus on the bugs on your branch. Then when you're done fixing your branch, no matter what's happened to the main branch, you can merge your branch back into the main branch. And Git's going to do all this automatically. And now the main branch has your bug fixes plus all changes that have been made on the main branch as well. And people have already merged other times into the main branch. That's also going to be resolved automatically by Git. Of course, there are some obvious issues with this, right? It's not going to handle everything automatically. So you can think of already, for example, if there was a particular method within your code that one person wrote a completely different thing for than another person, Git cannot resolve that automatically. It's going to ask you basically what you want to do. So in some cases, it's not fully automatic, but it's super convenient because you basically get to pick. It's just going to ask you like, yeah, what do you want to do here? And it's pretty straightforward. So merges are basically the core of how Git works, because you can then reapply changes back into the main version of your code. So now let's get into the collaborative aspect. So we're going to look at a little bit more open source software. So if you see an open source project on GitHub and you want to contribute, what you do is you fork it. And you can think essentially of a fork very basically as sort of like creating a branch of their whole repository. So now you've just created a copy of their repository. You can make your own changes, do whatever you want, create commits, create your own branches, merge your own branches, make whatever changes you need through whatever methods you need. And then you can create a pull request on GitHub back into the original repository. And those changes can be merged back into the original repository if that maintainer approves. Again, like we've been talking about, so far, open source does not mean open access. You cannot directly edit that other person's repository, but if they like your changes, if they test your changes, they can approve those changes. And if they like your changes and they approve them, and then they realize after approving them and committing the pull request that it breaks all their code, then they can just revert that really easily. So it's still super powerful in terms of like making sure the code is all working and undoing mistakes and stuff like that. There's something else I want to talk about here, but I might have forgot it. That's okay. We'll come back to it if I remember. So I'm going to basically review the key terms we went over so far. Then I'm going to stop for any questions, and then we're going to sort of get into tonight's activity. So these commands But it says key commands terms here because some of these terms are just like casual vocabulary phrases that we've discussed already, but some of them are, but all of them, excuse me, are literal commands on Git, the command line interface. And we'll talk about this in a second, but we do recommend in general, if you want to like actually get into collaborative coding or version or start understanding version control, that you download like a local version of Git as well. What we mean by version of Git is like a Git, a desktop client, or just the Git command line interface on its own or something like that. Anyway, these are all command line commands, which is what I'm trying to say. Clone is going to create a local copy of a remote repository. This can be your repository. This can be someone else's repository. It doesn't matter. It's just going to download the files essentially onto your computer. Check out is the command that Git uses to switch between branches really easily. So what we said earlier was that Git allows you to switch very easily. In Git, you technically don't call it switching, you call it checking out. Git makes it really easy to swap between branches locally or remotely. You can just, and it'll save your changes in the branch you've made before switching to a new one. And all right, we'll talk about this a little bit more in a second, maybe, but what that's called is a head. So basically, let's say you've made a bunch of changes on your main branch, but you didn't want to commit them yet for whatever reason. Maybe they're like unfinished and you don't want to have an unfinished commit in your commit history, because then it's like confusing if you look back and you want to revert it. And your policy is that you generally only commit finished changes, which is a typical thing. You can still swap to a different branch, like a beta branch or an experimental branch, if you want to make changes there. And Git will store the uncommitted changes you've made in what's called a head. So a head is an uncommitted commit, basically. It's all the changes that you've made to a commit that haven't been saved yet as a commit. Status is a very informational command. It's just going to let you see information on branches in the command line. Of course, this is much, much less useful if you, as we recommend, look at GitHub Online or look at a Git desktop client that has all of these visualization features that are going to make the status command basically meaningless. Fetch, like we said earlier, is a way to see which changes have been remade to the remote repository that you're looking at. So which changes your computer doesn't have on your files. Pull will then pull those changes onto your computer, make everything work automatically so that now your computer stores the online version as well as your additional changes. And then push is the exact opposite of that. It's going to alter the remote version without screwing with your code. Next up is some more commands related mostly to branches. So going back to the idea of a head, basically with Git, you get to choose what gets committed. So you don't necessarily, if you've made changes to a bunch of files, you don't necessarily need to store all those changes in the next commit. So what you do with the add command is just pick which files you want to save to the next commit before you actually commit it. If you use a desktop interface, this is the equivalent of this command is doing a little, like clicking a little checkbox next to the files that you've changed. So it's super, super simple. Commit will actually create a new commit. So that's going to store it in your commit history. It's going to make it really easy to revert back to or revert forward to if you're going in a previous version. And that's like a checkpoint, a save point for your changes. Revert, like I just said, is going to undo a commit. There's a bunch more commands in GitHub that can more like, because revert is pretty delicate. It's like, it won't always do what you want it to do. I'm not going to talk about that nuance right now, but there's a bunch more ways on GitHub, which are a little bit more dangerous because you can accidentally completely bulldoze commits and like just remove them. But revert is a nice, safe way to undo a commit. Branch is just the command to create a new branch, and then merge pretty intuitively is the command to create and to merge two branches together. On GitHub, this merge is, you do it by clicking a button. And on branch, you also do it by clicking a button. Actually, in fact, many things I've just mentioned on GitHub online, without even needing to install anything, you can do with a button. But the most common thing you will see is that like merges typically are done by a GitHub for open source repositories because it has all these extra features. It has this like code coverage checks that we've mentioned earlier. It has all these discussion features. So it's nice to have basically an online discussion in a big forum to say like, okay, have you checked over everything? Everybody gives it a thumbs up, click a button, it's done. Git merges it for you. So just to briefly mention some examples of the desktop GUIs we've been talking about so far. And again, just to very clearly distinguish that Git goes on the command line and it is a bit ugly and confusing to use. GitHub GUIs are used in conjunction with Git, you can still always access the CLI, the command line interface if you want to, but it's nice because you get to visualize a ton of stuff through these interfaces. Most of them are free and open source. If you're using something that deals with Git and isn't free and open source, that like kind of defeats the entire purpose, because the whole point of Git is that it's free and open source. So any partner software would be really weird to not do the same. So that's a great feature for all of them, is that they're nice and easy to use. They're free, they're open source. You can download them anywhere. Or sorry, not anywhere, but you can download them without like needing to sign up for some nonsense. Like we've said, they have all these easy features for visualization, so you don't have to type in all these commands. So things are just a bit more intuitive for you. And I don't know, this is sort of opinion piece in our workshop where we just recommend that you download them because they will make your life easier. Although you should absolutely familiarize yourself with the Git command line interface if you're interested in doing serious collaborative coding or version control. So I'm going to describe this project now. If you're watching this in the far, far future, this repository might be long gone, but the premise should still be the same if you want to set up your own repository and try this for yourselves. And I still might approve changes to this in the future beyond tonight. But basically, here's the idea. We're going to be doing this online only to prevent any kind of tech support or troubleshooting issues that we have to deal with right now in terms of people downloading Git or downloading any software. So if you go to the link, which we'll send in the chat in a second, you can create a GitHub account if you don't have one already. And then the goal is basically to test out all the features that we've just talked about. So you're going to fork this repository, which has basically nothing in it right now. You can create your own branches. You can make your own changes. And the idea is that we're just sort of crowdsourcing basic files, like whatever you want. By files, I mean like just like a programming language file that's supposed to do something when you run it, but nothing complicated. Like it can be as simple as a hello world file in whatever language you want, or it can be something a little bit more complicated, like maybe clicking a button in JavaScript or something like that. It doesn't have to be like runnable or anything, but just to create a basic file which contains something you like, maybe just prints your name or your birthday, again, whatever you want. Then you're going to use GitHub to create a pull request. And then I'm going to merge these pull requests into the original repository. And then the goal is, if we have enough time or people are interested, you can then re-pull my changes from the main repository and then make more changes and then contribute back into the main repository to sort of demonstrate how like open source software editing might work. So I'm going to stop the recording now while we work with our attendees right now to do this activity. Thank you for watching. If you're from the future, thank you for coming tonight. If you're in the past, if you're here right now, we're going to do this activity. If you have any questions about this recording and you're watching it soon after it was uploaded, feel free to email hackathons@steelcitycodes.org and we'll get back to you, or just talk in the Discord. We're always happy to help. Okay, I'm going to stop the recording right now.